Okay, guys, we got a lot to cover. Last week, I did not get as much done on Thursday night as I wanted to, so we got to make up for it tonight and tomorrow night. Just as a reminder for everybody, this Thursday, if you didn't know, you're in big trouble. We have exam number 2 this Thursday. I'll be at Mesa at 6 o'clock. You can start then. But of course, you know, you can come in anytime you want after 6. You don't have to be there at 6. Do bring your own paper. As usual, no notes, scientific calculator only, but you can do a brain dump. Okay, you can do a brain dump. So that would be a good thing to do. Show me the blank piece of paper. Just say, hey, Foster, look, you know, show me the paper, it's blank, and then start putting notes or examples or anything else you want on it. The other thing, and I'll talk about this a little bit more because I know people are still logging in. We're having a test on Thursday. Okay. The deadline to drop is Friday, the next day. Okay. And I sent you an email over the weekend, last Friday, explaining about the drop deadlines, explaining about some of your options. I will do my very best to grade this to grade this exam and put your grades up online by Friday, you know, midday, 2 o'clock in the afternoon kind of thing. Okay. So that you can make a decision whether you want to stay or drop in the class. The decision is yours. As of right now, I'm not taking roll anymore. I do keep track of who misses homework assignments, who misses quizzes, but I don't care. If you don't want to log in, you don't have to log in. I don't care anymore. Okay, we're done. So anyway, you have to decide whether you're going to drop or stay or drop. Okay, you have Friday. I think it's Friday midnight. Although, you know, I wouldn't wait till 11:59. I'd make my decision. But I'll get you as much information as I can. Okay, so you can make an intelligent decision. I will be hanging around on Friday, in and out. I have to take care of grandkids and stuff like that. But if you want to not text me, but email me, I'll try and answer your questions to the best of my ability. Tomorrow night, Wednesday, Lisi and I have a review program process set up. So if you want to stick around and do some reviewing for the exam, we'll have the class split up into 2 parts. Okay, and you can choose which you want, but I'll give you more information on that. All right. As I started a few minutes ago, I said we didn't cover enough stuff last Thursday in class. So I want to start covering that now. I'm going to start doing this totally out of order, completely out of order. In chapter 9.8 and 7.6, okay, that's one of the assignments in chapter 9. Okay, it is solving inequalities okay, and I can't stress this enough, my way. This is super important. When we get to the chapter 9 exam, that'll be exam number 3, the instructions will say, do this my way. If you don't, you will receive almost 0 credit. Okay, so I don't know if you've got a highlighter or whatever, this section has to be done the way I'm going to explain it. Okay, we're going to use a technique called interval test. Okay, now keep in mind, we're studying inequalities, less thans and greater thans. Okay, and we're going to use a technique called interval testing. Now, I will be honest with you. For some of the examples I'm going to give, There may be an easier way to do that particular problem. Okay, for some of the examples, there may be an easier way, but I'm using these so I can show you interval testing, because I promise you, you can't get out of calculus without using interval testing. You can't. Okay, they use it all the time. They may not call it interval testing, but they use the concept all the time. So I am going to show you and force you to learn interval testing, because I'm going to say do it my way on the exam. So let's start with an easy question, okay? An easy example, and I'm just going to show you how to do this. Let's start with this. X squared plus 6x is greater than or equal to 0. So this is called a quadratic inequality. Quadratic means power of 2. Okay, so one of the techniques we've learned is to factor. Well, we're going to do two things. We're going to pretend that it equals 0. And we're going to solve it as if it equals 0. So this one, we're going to factor what they have in common. Okay, split it up, x equals 0 or x plus 6 equals 0. Solve it. Well, this is already solved. So this is x equals -6. Okay, so we got x equals 0, x equals -6. Now, if this had been an equation at the beginning, we'd be done. These would be our solutions. But these are not called solutions. These are called critical values. They're important numbers, but they're not the answer. So some books call them CVs or critical values. Okay, they're not the solution. They're a way to get the solution, but they're not the solution by themselves. So how do we get the answer? Well, you take these two numbers and you put them on a number line. Here's 0, here's -6. Okay, and because it was equal to, okay, we can put solid dots on that. Now notice the two critical values divide the number line up into 3 sections. Each of these sections is called an interval. An interval is a section of the number line. That's all it means. So we're going to test in each section. Okay, what are we going to test? Well, the first section, and this is where I begin to lose people. So I need you guys to pay attention. I also need you to ask questions the minute you get lost. Okay, the first section that we're going to test is from 0 to infinity. That's the first section in the number line, from 0 to infinity. What are we going to do? We're going to pick any number at random, any number from 0 to infinity. What are we going to do with that number? We're going to plug it into the original problem. Okay, so here I go. I am going to pick a random number 2. I'm going to say I'm going to test 2. Now, this work is important. Okay, this is important, guys. So many students don't think, okay, I don't have to do this number line. Yeah, you do. This is your work. If I don't see this number line on your work on the exam, I won't give you credit. This number line with the word testing 2 is important. It's no pun intended, it's critical. What am I going to do with 2? I'm going to put it in the original problem. So I have 2 squared plus 6 times 2 is greater than or equal to 0. That's 4 plus 12. That's 16 is greater than or equal to 0. That's true. So I expect to see a number line with dots at -6 and 0, the word test2, and then your result. It's either true or false. Okay, I don't need to see this work here because sometimes you can do it in your head, but I do need to see the result. So I need to see the words testing2 in this case, and then the result was this is true. So I write true up here. Okay, I do it again. So I'm going to pick a number in this interval. Okay, from 0 to -6. Pick any number you want. I mean, heck, if you really wanted to be silly, you could test -1.7 if you really wanted to. Okay, but remember, you pick a test number, you have to plug it back into the original problem and work out the arithmetic. So let's be lazy. Okay, let's remember, we're the few, the proud, we're the lazies. I'm looking for a red pen that doesn't smear. Okay, let's try this one. Let's test -1. Can you guys, is the orange? That doesn't come out very well, does it? Oh, well. All right, I'll just use black. I'm sorry. Test -1. Okay. Again, we're always going to test it in the original. So I have -1 quantity squared plus 6 times -1, okay, is greater than or equal to 0. I'm taking my test number and plugging it into the original. Okay, so this is 1 plus -6. So that makes -5 is greater than or equal to 0. So question, is -5 bigger than 0? No, so you write false. Okay, I'm going to erase my work here. Okay, last interval, okay, from -6 back to -infinity. From -6 back to -infinity. Pick any number you want. Any number, it doesn't matter. Okay, I'm going to, in this last interval, I'm going to test -10. That's going to be my test number. So I'm going to plug it here. -10 squared plus 6 times -10 is greater than or equal to 0. So you have 100 plus -60. That's 40. Is 40 greater than or equal to 0? Yeah, it is. True. Okay, so I'm going to erase some of this stuff. Does anybody have any questions to this point? Pretend it's equal to 0. Solve it, get critical values, not solutions, but critical values. Put those critical values on a number line. Okay, 2 critical values, split the number line into 3 sections or 3 intervals. And then we just pick any number that we want. Okay, I chose in this interval, the interval from 0 to infinity, I chose to test the number 2. Somebody could have picked 1. Somebody could have picked 10. It doesn't matter. We all should get true. Okay, and what that means is that this whole, any number I would have picked here would have made my problem true. Because this interval here is false, this means any number I would have picked, not just -1, but any number I would have picked makes this thing false. And similarly, everybody here is true. So questions before I jump to the answer? Any questions at all before I jump to the answer? Okay, then we go back to something we studied a long time ago, okay, and you probably mostly forgot. Our answer is whatever is true. Our answer is truth. So what's true? From negative infinity up to 6. Negative infinity, comma 6, bracket. Remember when we studied the parentheses and the brackets? What else is true? From 0 to positive infinity. And we want to them together, union them together, that the U was mom's way, or actually it's a mathematical way, not just mom, of saying this answer combined with this answer. That's what was true. So this whole thing here is our solution. That's it. That's our answer. Okay. That was example number 1. Questions? Okay. So how are you going to get points on this when I grade this? Okay. You're going to get some points for getting the correct critical values. Okay, remember critical values, we pretend it's an equal, we solve it as if it's an equal, but those aren't our answers. You're going to get points for putting the critical values on a number line, choosing test numbers, plugging the test values into the original problem, and getting true or false answers. Okay. And then you're going to get points for, did you correctly interpret the true and false? Whatever was the here, okay, did you put the correct thing down here? Now, let's say you screwed up your interval test. Let's say you screwed up your arithmetic, okay? But what you wrote here agreed with your arithmetic. You will get more credit for that than if you fail to do this. If you don't do this, then there's no way you can do this. All right, enough. I'll go over that. I want to do another problem. This was a quadratic inequality. Okay, we used interval testing. Last shot, I need to erase it before I go on. Any questions? Okay. Then another example of this. A new example. Absolute value 3x minus 7 less than, oh, I don't know. Let's go 16. Okay. So here we go again. See, we got to dig way back. But one of the reasons I like teaching this is because it forces you to go back and remember what we learned. We learned this. You just forgot it. The absolute value of 3x minus 7, we pretend that it equals 16. Now, if you recall, absolute value equations always split into 2. After you've isolated the absolute value, that means you got this chunk alone, you split it. And we said, okay, either this quantity was worth 16, because the absolute value of 16 is 16, or this is worth negative 16. Okay, we don't know which. This is either worth 16 or negative 16. We don't know. So we have to account for both. So we say 3x minus 7 could have equaled 16, or 3x minus 7 could have equaled negative, whoops, 16. So add 7, 3x is 23. Divide, x is ugly, 23 over 3, which, well, I don't know what that is, 7 2/3? Yeah, I think that's 7 2/3. You could leave it 23 over 3. I'll show you why 7 2/3 in this instance might be better, but 23 over 3 is fine. Okay, here we're going to add 7 to both sides. So we have 3x equals, I believe that's -9. Divide both sides, we get x is -3. Okay, I avoided the glare. Yay. So again, keep in mind, these are my CVs. These are my critical values. They're not the solutions. These are just critical values. The solutions are near these or around these. Okay, so that's okay. Now, how do we do it? Well, we put these two numbers on a number line. We have -3 is a number, and 7 2/3 is a critical number. And this time, notice it's less than, not equal to. So I know that it's going to be open circles. Okay, so pretended that my problem was equal, solved it as if it were an equal, and got critical values. Then I put the two critical values on a number line. And remember, you have to show me this number line. And now you start picking numbers at random. Okay, we have 3 intervals or 3 sections. We have the section from 7 2/3 out to infinity. We have the section between -3 and 7 2/3. And we have the section from -infinity up to -3. We have 3 sections. So you're going to pick 3 test numbers. Okay. This one out here, I'm going to test probably 8. I don't know, but you could test 10. It doesn't matter. You could test 15. You could test 107. It doesn't matter. Okay. Just pick any number from that's somewhere between 7 2/3 and infinity. What do you do with that? You plug it into the original problem. So you have the absolute value of 3 times 8 minus 7, okay, is less than 16. 24 minus 7, that's the absolute value of 17 is less than 16. But absolute value makes everything positive, so you have the statement 17 is less than 16. So this is just arithmetic, guys. That's all you're doing here. After you plug in the 8, you're just doing arithmetic, and you're asking, is my answer true or false? That's all you're doing. Taking your test number, plugging it in, doing arithmetic. This is false. Okay. To make room, I need to erase my arithmetic here. Do you want me to stop while you guys catch up? Okay. I would like to erase my arithmetic right here. I'm waiting for someone to yell at me. Okay. Cool. So now, oops, this was 7 2/3. So now I'm here to this interval. I need to pick a number somewhere between -3 and 7 2/3. Remember, when you can, try to use 0. We're lazy. Math with 0 is easy. Use it. So we take 0, plug it in the original. We have the absolute value of 3 times 0 minus 7 is less than 16. Well, 3 times 0 is 0, so this is the absolute value of -7 is less than 16. But hang on, what does absolute value do? Absolute value turns whatever's inside, the answer inside, to positive. So is 7 less than 16? Yes, it is. So we write true. Okay. Last section. I need a number somewhere between -3 and -infinity. Again, it can be any number you like. Okay. I am going to choose -4. But you can choose anything you want. So I'm going to plug it in here. Absolute value of 3 times -4 minus 7 is less than 16, not equal. So this is -12 minus 7. This is the absolute value of -19 is less than 16. Sorry, it's in the glare. But the absolute value of -19 makes it positive 19. So is 19 less than 16? Nope, false. Okay, to reiterate, a couple people I logged in late were solving inequalities using a concept called interval testing. I suggest you go check out my video later tonight or whatever. But we pretend it's equal, we get critical values. You must show me this. We take the critical values and put them on a number line, 7 2/3, -3. Okay, you pick random numbers from each interval. Some number from 7 2/3 out to infinity, you pick that number, you plug it into the original problem, and you determine, is my answer true or false? And you do that for each interval. This number line with the words false are all required of me. Your instructors in the future may have slightly different requirements. I know, for example, on the AP Calculus exam, when they do this, they insist that students write tables to do this. X is less than -3, 0, or and whatever, and then you pick your test number, and then you put your work, and the students have to organize their work in a certain way for the AP exam. This is much easier to do. Trust me, much easier. But again, this is something you will be doing a lot in calculus. Okay, now the answer is what's true. Well, what's true is everything in between -3 and 7 2/3. Because everything else was false. So my answer is parenthesis -3, comma, 7 2/3. Or if you wanted to say 23/3, that's up to you. But this is your solution for this problem. Again, for this problem, there might be an easier way. But for my exam, I want you to show me interval testing, because I'm trying to force a technique on you that will be useful all the time, not just once in a while. All right. I'd like to do one more example. Anybody have any questions on what I'm doing up here? Okay, this is new. This is weird. People don't like it. Okay, till you get it. Again, I just got through saying this. Yeah, for this particular problem, for absolute values in general, there is a slightly easier way to do it. Okay, I'll be honest with you on that. There is, but okay, interval testing works when you've forgotten all the tricks. This technique called interval testing that I'm teaching you here works after you've forgotten all the tricks, after you go, oh man, I thought I knew how to do it. Now, if you know how to do this, you know how to do every inequality, solve an inequality. You really do. This is a great, great tool. Are there faster ways? Sometimes, yeah. But this way works always. All right, I want to erase this and do one more example of this. Any questions before I erase? Okay.
So do you, sorry,
That's okay. What? Go ahead. Shoot.
you only put the union sign when the middle is
When
false.
there's two different sections that were true, then you put the union sign to kind of tie those together. Yes.
Okay.
Okay. It's, as an aside, just to kind of expand upon your question. Okay. Suppose I give you some problem and you had, let's see, -1, 0, 5, 9. And let's just say these are all solid dots. So on some really complicated problem, okay, I gave you, these are the critical numbers. And let's just say you did the math and this was true out here. This was false. This was true. This was false. And this was true. Okay, now don't panic. I'm not going to give you anything that's complicated, but this will be a nice way of kind of showing you what we want. Okay, so I gave you some crazy inequality problem. You got the critical values, you put them on a number line, okay, and you figured out by whatever test values you used, this was the true, false, true pattern. Okay, we want to know what's true. So the solution is from -infinity to -1 bracket. Okay, jump up to here, union 0 to 5 bracket. Jump up to here, union bracket 9 to infinity. So when you have a bunch of true sections, you just tie them all together with that union symbol, that capital up or capital U. Does that clarify?
Thank you.
Yeah. Now, guys, don't panic. You're not going to get anything as ugly as this. But this is meant to demonstrate, okay, all we care about is what's true. And then you just tie all the two sections together with a U between them, the union symbol. All right, I want to do one more problem. Anybody? Questions before I erase? Okay. Okay, last example. 5 over x plus 1 is less than or equal to 1/3. Now, this is a super tricky problem. Okay, this is a super tricky problem, so I hope you're going to pay attention. The first thing we're going to do is write this as 5 over x plus 1 equals 1/3. Okay, and I go, oh, well, look, I can cross multiply because it's a proportion. A proportion was when one fraction equals one fraction. So I go, cool, I can cross multiply. So when we do that, we have 1 times x plus 1 equals 3 times 5. Or x plus 1 equals 15. Or finally, x equals 14. Now, be very careful. I feel like doing an Elmer Fudd. Be very, very careful. The wascally wabbit is going to get us. Does anybody know Elmer Fudd? I think he was in Space Jam, but I grew up on him and his cartoons. He was in both Space Jams. Here's the problem. There are two critical values in this. And x cannot equal -1. Huh? Remember we talked about restrictions. In fact, that's going to be a question on exam number 2. What are the restrictions on x? What makes a fraction undefined? Well, that's where you take the denominator of the fraction. Okay, you take x plus 1 and you say it can't equal 0. That's how we find restrictions. So solve this one, x cannot equal -1. That's pretty critical. Because if x were -1, this whole fraction would blow up. So this has a hidden critical value. And that's something you have to bring to it. You have to go, oh, I remember fractions have restrictions from the denominator. Okay, super, super important. Remember I told you this was kind of a difficult problem for students. The first thing you do is pretend it equals. Cool. I saw this as a proportion, so I got to cross multiply. I got my equal answer, x equals 14, but I also have a hidden critical value here. X cannot equal -1. So I put those on my number line. I have -1 and 14. Okay, now hold on. Do I use solid dots or open dots? Well, because it was less than or equal to, you would think I would use a solid dot. And you would be right for the 14. But x can never equal -1, ever. Okay, so you have to use an open dot on the -1. So again, we're requiring you to think critically. Okay, first off, this was hidden from us, the critical value of -1. Secondly, it has to have an open circle, because no matter what the rest of the problem is, x can never equal -1. All right. Now, when we test, this is going to be icky. That's a technical math word, icky. Okay, because we're going to have fractions here. Oh, crap. So I hope you're doing pretty good with your calculator. But if you think about things a little bit, okay, it might not be too bad. Let's see. 14. I don't know. Let's test, I guess, 15. I can't think of anything better. Okay. Maybe after you get the hang of this, you guys could see an easier way to test, but we'll work on this. So we test 15. So we have 5 over 1 plus 15 is less than 1/3. Well, that's 5/16 is less than 1/3. Hell if I know. So you know what I'm going to do? I'm going to do my calculator. I'm going to go to my calculator and use decimals for a moment. 5 divided by 16. Oop, okay, this gets me 3.125. Not 0.3125. And I know that 1/3 is 3333333 repeating forever. 3.125. So is 0.3125 smaller than 0.33333? Yes, it is. How do you know? Because you compare. Okay, first place, they're the same. Next decimal, 1, 3. 1 is smaller, so the whole fraction is smaller. So this is true. Okay. All right, here. I'm going to test 0. 0 would be really cool because 0 plus 1 is 1. Okay, so I'm going to say test 0. And I'll plug that in. So that's 5 over 0 plus 1 is less than or equal to 1/3. Well, that's 5 over 1. Okay, which is just 5. Is 5 less than 1/3? No. Okay, that's a definite false. And back here, what would be a good test number? Ooh, now you don't have to think this hard. You have your calculator, cool. But I'm going to use -6 as my test number, test -6. I'll circle them so they stand out a little bit better. Because I know that -6 plus 1 is -5. And that makes my arithmetic easier. Now, you have your calculator, go ahead and shove everything into your calculator. It's okay. But I like to think about that anyway. So this here is 5 over -6 plus 1 is less than 1/3, less than or equal to, I'm sorry. So that's 5 over -5 is less than or equal to 1/3. But that reduces to -1 is less than or equal to 1/3. Well, yeah, all negative numbers are smaller than any positive number. True. Okay. So I'm going to erase my work. Notice I erased my arithmetic. I did not erase the interval. That's part of your work. You know, where I keep writing in capital letters, no work, no steps equals no credit. If you don't show me this on your paper, then you're going to get no credit or very little credit. I might give you 1 point for getting the critical values and then heck with the rest of it. All right, so I got to get truth. So on this particular problem, we go from negative infinity up to -1, and they both have parentheses because of that open circle there. This other section over here has a bracket at 14, goes to infinity, that one. And because there's two sections, we tie them together with the big U, the union symbol. And that's the answer. Okay. I would like to move on to another topic. Any questions? Okay. I know a couple people had asked me about this last Thursday. I was planning on getting to this last Thursday. So for the few people that had asked me about it, does this answer your question? I hope it does. Okay. All right. So that's the last homework section in chapter 9. Okay. Inequalities my way. All right. I want to erase all of this and do another topic. Okay. Quickie review. Chapter 9 is all about solving quadratic, which means power of 2 equations. Okay, solving quadratic equations. Can't tell if that is ink. No, it's out of ink. That's why it wasn't doing a good job. Okay, from before, our techniques are factor. Okay. Then there's something called the zero. No, excuse me, wrong. The square root property. And the square root property only works if all of your x's are inside a quantity square. And you have to remember to add a plus or minus in. So factoring was chapter 7. And we've been going over that and over that and over that. Solving, okay, quadratic equations by factoring. But we've seen that some problems don't factor. Some problems like use the square root property. Another one they use, okay, is something called CTS. That's called complete, P-L-E-T-E, complete the square. Okay, I have a few homework assignments on Mom on that. If I give you maybe one question on the chapter 9 test, okay, that's about all you're going to get on this. Completing the square is useful. I'm teaching it to you now because it's going to be really useful in the future, chapter 11 of this course. So I want you to see it now, okay, practice it a little bit. It will become super important in chapter 11. But I'm just kind of giving you a heads up right now. And then there was the quad formula, quadratic formula. Okay, and if you went onto my Canvas site, you will find a couple songs that people have invented to help you remember the quadratic formula. Whatever, you must remember it. This is one of the key things. If you say, I passed intermediate algebra, man, you better know how to whip numbers into the quad formula and do it correctly. Factoring is one key issue, quad formula is another. These are nice, but they're not critical. Quad formula is critical. Factoring is critical all over the place, not just solving. Okay, when I taught the quadratic formula last week, okay, I taught it as an if-then. If you had ax squared plus bx plus c equals 0. And then I spent some time taking that apart and analyzing it. Okay, it says if you have a power of 2 and only a power of 2. If you have a power of 3, you can't use the quad formula. If you have a power of 1/2, you can't use the quad formula. It only works for power of 2. But further, it implies that your powers must be in order. It must be a regular old trinomial in order, x squared, x constant, and it must equal 0. So it's got some conditions written into the formula. If your problem is written this way, then your answer, x, is the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Now, most books, in fact, no book puts parentheses around the b like I did there. Well, I do that because I've seen people make just silly arithmetic mistakes. So I like to emphasize we can take the whole b value, whatever that number is, all of that, and square it. I also emphasize that you do 4 times a times c first. You do the power, then you do 4ac because those are multiplication. We're doing PEMDAS. You do that first. And at the very last, you do the subtraction. We're following PEMDAS here. And I pointed out last week that if there's one place students are going to make mistakes, it's going to be right in here, arithmetic. Okay? So that's the formula you do somehow, some way, have to memorize. X equals opposite of b plus or minus the big giant square root of b squared minus 4ac. And then the whole thing, please notice this, the fraction bar extends under the b. It's not just this part is divided by 2 times a, it's the whole thing is divided by 2 times a. So students get kind of lazy, they don't write the fraction bar all the way out here, and they end up making a dumb mistake. So we're going to add to this tonight, but these are the skills that you're going to be required to show on the Chapter 9 exam. Okay. Can you solve by factoring again? Okay. Can you use the square root property? Remember, the square root property says all of your x's are inside the quantity squared. And somehow you got to throw a plus or minus in there. Can you use completing the square? And can you use the quad formula? So, quickie review. Okay, take about 2 minutes to solve that using the quadratic formula. 5x squared equals 7x plus 1. Okay, so by this formula here, we want to make it equal 0. So I'll take away 7x from both sides, and I'll take away 1 from both sides. So when I do all that mess, which you could probably do in your head, you have 5x squared minus 7x minus 1 equals 0. Okay, so it's in the proper format. One of the things I talked about last week was if I was in high school, I could intimidate the students and force them to write a equals 5, b equals -7, c equals -1. I think that's a good technique. I think you should write it down, but I cannot force you to do that. The a is always the number in front of the x squared. The b is always the number in front of the x. Notice in this case, b is a -7, so we're going to be careful there. And c is the constant term, -1. So we pop everybody into the quad formula. It's x equals negative of -7. Notice it says negative, or I said, excuse me, the opposite of the b number. So if my b is -7, I'm going to get a +7 here in a minute. Plus or minus the square root of -7 quantity squared minus 4 times 5 times -1. All divided by 2 times 5. So -7 is +7, 2 times 5 is 10. I'm going to go off to my scratch paper and work this thing out. -7 squared is 49 minus 4 times 5 times -1 is -20. Be careful. 49 minus. The formula has its own minus sign in it. Right there, there's a minus sign right in the middle of the formula. The fact that this number, -20, also happens to be negative, well, what do we do with a negative? Add them. So we get 69, okay? So inside here, for vocabulary purposes, that's called the discriminant. Don't worry about it. Discriminant is the number inside the square root. It's called that for a reason, which I'm going to skip. Okay. Now, we do need to worry. Can I break down 69? What goes into 69? Well, off to my scratch paper, if this was 69, I know 3 goes into that. That's 23. Well, I can't break it down anymore. I can't take square roots of anybody. So that's about as far as I can go. That's my answer right there. I should put it in a solution set. Solution set 7 plus or minus square root of 69, all divided by 10, and I'm done. That's about the easiest, most straightforward example I can give you of the quad formula. Any questions on that example? Okay, we'll try another example. I would like to erase these notes here. Does everybody have them copied down? Anybody gonna scream at me? Okay. Now, this particular problem that I'm going to do here has a little bit of a trick to it. Three x to the third plus 2x to the second equals negative 9x. Okay. You can't use the quad formula right away. Okay, so I'll pause, give you a couple minutes to play with that. Kind of working this one out in my head, and this is going to have all kinds of nasty tricks to it. I need to erase this other problem because this is going to be kind of a complicated problem, so I want to show as many steps as possible. So let's start over here, and then I'll erase that. First thing I did is I made it equal 0. Second thing I noticed is I can't use the quad formula yet because it's a power of 3, but I can factor out the x that they have in common and then split it up. So x equals 0 or this equals 0. Now, since I factored out the x, I can use the quad formula on this part of the problem. Okay, because it's a power of 2. There's another thing here that I keep hammering. Most of the time when it's a power of 3, you're going to get 3 solutions. Okay, when this was a power of 2, we got 2 solutions. We got 7 plus square root of 69 over 10 and 7 minus square root of 69 over 10. So that was called the fundamental theorem of algebra. Okay, I kept saying it was unimportant, but it keeps coming back to bite us in the butt all the time. It predicts how many solutions we should end up with. Well, there's one of them right there. And we're going to get 2 more from there. Okay, I'll start doing the problem. Can I erase this though? Make room for my work? Anybody gonna scream at me? Okay, so for my quad formula part of the problem, I get A is worth 3, B is worth 2, C is worth 9. Okay, so I'll start down here. X is negative of 2, opposite of 2, plus or minus big giant square root 2 squared minus 4 times 3 times 9, all divided by 2 times 3. x is -2 plus or minus square root. Okay, it's somebody over 6. I know that much, over 6. That's going to be, what's 12 times 9? 88. I think I need a calculator. $108. Well, it's going to be way off. Okay, so I have 4. Well, I guess I'll show more work. 4 minus 108, which is x is -2 plus or minus the square root of -104, all divided by 6. So let's pause right there. We're not done by a long shot, but are we okay so far? Okay, so the first thing I have to do is take the I out. So I have x is -2 plus or minus I times the square root of 104 over 6. But wait a minute, square root of 104. Two radical 26. So x is -2 plus or minus. I could take a 2 out and have a 26 left inside over the 6. Square root of 104 was 4 times 26. That's how I could simplify it to that. I'm not done yet, but we're doing a lot of steps. This one problem has just about everything in it that we've studied. Okay, it's got a little bit of factoring. Okay, it's got imaginary numbers. It's got simplifying radicals. Okay, it's got everything in it. It's a good problem. It would be a really neat one. I would put that in my notes, make a little flashcard of that. Make sure you know how to do every single step and why. Don't memorize the problem. That's silly. Memorize the why. Why did I do this step? Why did I do this other step? All right. One last thing. This answer does reduce. People were having trouble with this. Okay. I look at what I call the normal numbers, 2, 2, and 6. I is not a normal number. Square root of 26 is not normal. But 2, 2, and 6, those are all normal. What do they all divide by? 2. I could divide everybody, top and bottom, by 2. Now, hang on. I'm going to write this wrong. Don't copy this down yet. Okay? People do this. They write x is, okay? Okay, 2 divided by 2, that cancels. So I get plus or minus 1i radical 26 over 6. Because they thought the 2 and the 2 cancel each other out. Okay, what does -2 divided by 2 actually mean? Isn't it -1? Okay, don't forget that. You're dividing -2 by 2, regular 2 by 2, 6 by 2. So this should be a 3 down here, dummy. Yeah. Okay. And lastly, if, can you guys all read that, or do you want me to move it out of the glare? I'm sorry, I didn't realize. I'll rewrite it out of the glare. I'm sorry. Okay. The last thing we kind of maybe need to worry about is, remember, big discussion last week on separating the real from the imaginary. I dropped the 1 in front of the I because it wasn't necessary at all. Sometimes some books, some problems want you to separate the real and the imaginary. Other times they don't care. I won't care. Your future instructors might care. So you just got to roll with the punch and just go, okay, that's the way you want it. They're actually more correct than I am. Okay, questions on this one? Want to do one more of these and then we'll get into the last topic of the evening. Questions on this one?
Do you not put the 0 in the solution set?
Oh, damn it. Thank you. Thank you for pointing out how stupid I am. Damn it. Thank you. Okay. Yes, absolutely you do. I was wrong. And all of that is on video and been recorded. So everybody, hello, I'm stupid. Okay. But we knew that from before. Thank you very much. Okay. All my talk. Okay. Big fancy talk about the fundamental theorem of algebra. We're supposed to have 3 answers. Yeah, the 0 was one of the answers. I should have put it in solution set. I screwed up. So it should have been solution set 0, comma, and then the 2 answers here. -1/3 plus or minus I radical 26 over 3. Thank you for catching that. And I mean that in all sincerity. I'm mad at myself for falling into that trap, but thank you. And actually, it's pretty good because it makes a point. Anybody else? Good catch. Anybody else have any questions or comments? All right, one more of these, then we'll take a break. Then we'll go on to the weirdest stuff you've ever seen in your life. I mean, weird. Really weird. Okay, I do need to erase all of this. Questions on it before I erase. Anybody get to yell at me? Okay, here we go. Okay, so last example, before we go into really weird stuff, 4x times the quantity x plus 1 equals x minus 3 quantity squared. I want to solve this probably using the quadratic formula. Remember, it must be in order. It must equal 0 before you even start to do the quad formula. So I'll pause this, give you a few minutes to give it a try. Okay, for the sake of the recording, you had to distribute the 4x into this mess. You had to square this binomial properly. That means you had to write it down twice and either use the matrix box or the FOIL method. At any rate, you get this. Got to equal 0, so you take x squared away from both sides, add 6x to both sides, subtract 9 from both sides, you get this mess. Okay. No one's yelled at me yet, so I assume I haven't made a mistake. My A value is 3. My B value is 10. My C value is -9. So let's see, x is -10 plus or minus the square root of 10 squared minus 4 times 3 times -9 all over 2 times 3. So x is -10 plus or minus the square root of somebody over 6. I think that's 208. Ah, yeah. So for what it's worth, you have 100 minus -108. So that was 208. So x is -10 plus or minus the square root of 208, all divided by 6. Okay. Does 208 do anything? It should. Yeah, 4 root 13. So x is -10 plus or minus 4 root 13 all over 6. And again, looking at my normal numbers, -10, 6, and 4, they all happen to divide by 2. So I get x is -5 plus or minus 2 root 13, all divided by 3. And actually, I'll just throw that in the solution set and I'm done. Questions? All right. I have to go feed the dog. I have to get a drink of water. Let's take about a 5-minute break, and then we'll come back and learn the weirdest stuff ever. All right. Last topic for the night. For what it was worth, chapter 9.3 was the quadratic formula. And we're going to now do chapter 9.4, which has a variety of different names. They are called quadratic-like equations. They're called equations that are reducible to quadratic. Okay, they have several names. What they are is really weird. Okay, and yeah, we have to cover them. First off, let's look at a quadratic equation, a basic quad equation. When you look at ax squared plus bx plus c, there's a very, very important relationship. Yes, I'm recording, good. Here, the power on the x is a 1. It's implied to be a 1, and this is a 2. So what's happened here is this power is always double this power. The highest power is double the lowest power, always. Now, that's going to be kind of critical, okay? Because what I'm teaching, what I'm going to show you in a few minutes, requires that relationship, that the highest power be the double of the lowest power. If they're not, then there's no way to do the problem that we know of at this time. Okay, they will all be this way for now because I'm trying to teach you something really new and really weird. Okay, but that's something you should be checking. What we are going to use is something called substitution. We're going to substitute. We're going to get nice in place of ugly. And then we're going to, at the end, well, we're going to solve. And then at the end, we're going to unsubstitute. Okay. The problem with all of this is that no problem is exactly the same as any other problem. And it pulls in skills from several different sections. Okay, so like if you've been blowing off, the square root property, where you got to put the little plus or minus, if you haven't been doing that, or if you're not sure about that, guess what? It's going to be important in this. Okay, if you're not very good at factoring, guess what? It's going to be important in this. Okay, so what I like about this one is it causes you to think a lot and to use previous skills. Okay, it builds on those previous skills. So you kind of see why we were studying them. All right, so quadratic or quadratic-like. In other words, they're going to be kind of quadratic, but not really. We'll fake it. We want the highest power to be double whatever the smallest power was. And we're going to use the substitution technique. So let's just get in and do a problem and just see. Okay. I will for sure come back and review this because it's weird and new. So if you don't get it tonight or tomorrow night, don't panic. Okay, don't panic. We'll come back and pick it up. So this is chapter 9.4. These are quadratic-like. Okay, so here we go. Notes. We're going to solve this problem. X to the fourth minus 11x squared plus 28 equals 0. Okay. Now, I'm going to do some steps. You're probably going to go, huh? And I'm going to say, don't worry about it. Just do what I do. Okay. They'll make sense after you've had some practice. First off, is this quadratic-like? Question. Is the highest power double the lowest power? Yes. Then I can continue. We do a substitution. Okay. You can use any letter. For some strange, really stupid reason, whenever math substitutes, they use the letter U. I don't know why, but they use U. And we always let U be the smallest power, the variable with the smallest power. Always let U equal the variable with the smallest power. Okay. Well, what that implies then, if you squared both sides, that means U squared is x to the fourth. Because if you square both sides of this, then you're going to get this. Well, that's kind of cool, because what that means is this problem now, instead of x to the fourth, it's going to be U squared minus 11U plus 28 equals 0. So in other words, we're using that as our substitution. U is the same as x squared, and U squared is the same as x to the fourth. Okay, it'll work every time. If the highest power is double the lowest power, then this, whatever I'm doing up here, will work every time. So now, how do I solve this? Well, we're going to factor it, okay? It turns out okay, this is AC factoring, or I showed a few of you guys the belly button technique. This is AC factoring, okay? AC is 28, 4 times 7 is 28, so your numbers are 4 and 7. So we split it up, we get U minus 7 equals 0, or U minus 4 equals 0, which means U is worth 7, or U is worth 4. Okay, that's pretty cool. So we substituted. We got rid of the messier or the higher or the uglier powers, okay, and put smaller powers in its place. And we got U equals this. Here's the problem. And this is where most students will follow this, and then right about here, they get lost. So hang with me, I'll go slow. Most students can get down to here. Okay, but we want to go back to our original variable. It's always solve for X, not solve for U, solve for X. So what was X worth? Well, U is worth X squared. So we can say, X squared equals 7, or X squared equals 4. Okay, so what we just did is what I said, unsubstitute. We substituted for U, and we got a nice, pretty answers. Now we're going to unsubstitute, go back to X. How do I know? That's telling me U is the same as X squared. Okay, well, now, what about X squared equals 7? That's that square root property. To get X alone, I can take the square root of both sides. Okay, that's going to give me X equals plus or minus the square root of 7. Got to remember that plus or minus. So the square root property, when you take the square root of both sides, it introduces a plus or minus on the side opposite from the X. Well, we can do the same thing over here. Okay, we can take the square root of both sides. Okay, that's going to give me X equals, am I in the glare? Yeah, I am. X equals plus or minus the square root of 4, but square root of 4 in this case is 2, so X is plus or minus 2. Okay. The fundamental theorem of algebra says if you have a fourth power, you're probably going to have 4 answers. There they are, plus or minus radical 7, plus or minus 2. So your solution set would be something like this. And again, it doesn't matter what order you put them in, but you got that. Now, that was probably new to just about everybody. So I'm expecting a whole lot of questions. None, huh? Okay, then. I would like to, well, I'll try and leave that up there and see if I can do some work without erasing too much. A new type that will scare the heck out of you. Six x to the 2/3 minus x to the 1/3 equals 12. Holy crud. All right, well, hang on a minute. First off, is the highest power double the lowest power? In other words, if you went to your scratch paper and did 2 times the lowest power, 2 times the lowest power, does it equal the highest power? Yeah, it does, which means I can go ahead, which means I can use this trick, whatever I'm doing. Okay, if that was false, then I couldn't do the problem. So here we go. Again, why mathematicians use, I'm not going to use U, I'm going to use R. Okay, you can use any letter you want. Just you can't, okay, that was wrong. You can substitute any letter. I said mathematicians like the letter U. God knows why. Okay, I like the letter R. I don't know why. The only letter you can't use in your substitution is the original variable. You use anything else but the original variable in the problem. So I'm going to let R equal x to the 1/3. What that implies is if you squared both sides, is that R squared would be x to the 2/3. Just trust me, it will be. Okay. So now this becomes 6R squared minus R, okay, minus 12 equals 0. Huh? Be careful. Remember, it's got to equal 0. If you're going to factor it or quad formula it, it must equal 0. So you had to subtract 12 from both sides. And I just kind of did that automatically. Okay. This is ugly. This is a way ugly problem. There's no getting around it. Okay. This is an AC problem. So AC is -72. So what times what multiplies to -72 and adds or subtracts to -1? -9 times 8. So we come over here, that's 6R squared minus 9R plus 8R minus 12 equals 0. Just a reminder of AC factoring. Okay, factor out a 3R here. Leaves R minus 3. Factor out a 4 here. Oh, excuse me, this isn't R minus 3. Sorry, this is 2R minus 3. And factor out a 4 here, still leaves 2R minus 3. Bring the 2R minus 3 in front, factor it out some more, leaving 3R plus 4. All equals 0. Phew. So in the middle of this new problem with these stupid fractional variable powers things, okay, we have to go back and remember how to do factoring again. All right. Cutting to the chase to pick up the speed, we have 2R minus 3 equals 0, which means R is worth 3 over 2. Add 3 divided by 2, or 3R plus 4 equals 0, which means R is worth -4 over 3. Okay, remember a few weeks ago when if we got there, we would have been delighted? Yeah, we're not even done. We're not close to being done. Okay, so why not? Well, because we have to unsubstitute. Remember over here, we got a U answer, but then we had to go back to our original variable, an X. Where did I know, or how did I unsubstitute? Right there. That's what tells me what my substitution is. whenever I wrote the word let. So instead of r equals 3/2, I can say x to the 1/3 equals 3/2. And again, instead of r, I can use x to the 1/3 equals -4/3. Okay. I don't actually use this over here anymore. That just helped me get started. So from here to here, we unsubstituted, we went away from our nice pretty variable and went back to our ugly variable because of that. Okay, I need to erase the board here. Okay. I'm going to come back up here so we have room to look at it. X to the 1/3 equals 3/2, or x to the 1/3 equals -4/3. Okay, we're going to take a test in 2 nights. And some of the questions are going to have fractional powers. X to the 1/3. X to the 1/3 is the cube root of x to the 1st. X to the 1/3 is the cube root. Remember, the denominator of the power is the index. So this problem actually is the cube root of x equals 3/2. Okay. How do I get rid of a cube root? With a cube power. Cube power, cube root, x equals here, 3 to the 3rd is 27, 2 to the 3rd is 8. Now, some of you don't need to switch from fractional powers to radicals in order to do this problem. Some of you understand that you could just raise both sides to the 3rd power. And when you do a power raised to a power, you get x to the 1st power, because these are reciprocals, equals -64/27, which means x is -64/27. So solution set, 27/8, and whoops, -64/27. Okay, don't read too much into the fact that these are both have 27 in it, or 8 squared is 64. I tried to pick problems that has nice pretty answers. That's why these seem to be kind of related in some weird way. They're not necessarily always related like that. So let's go back. What did I do? Okay. After I wet my pants because I saw fractional powers, I did a substitution. I let r be the smallest power. That meant I could write this problem as 6r squared minus r minus 12 equals 0. That meant I could factor it by whatever means I have, or I could have quad formula it. But here's a clue. Every single one of the ones from section 9.4 will factor if you do the substitution correctly. Then the rest of the problem will factor out, so you won't have to use the quad formula. But anyway, so we use the AC, we get it down to here. We split it up, solve the babies to here, and then we have to decide, oh, I have to unsubstitute it. So in place of r, I put what r was worth. R equals x to the 1/3. That's what I wrote. Same thing over here. X to the 1/3 is -4/3. And then I had to figure out how to solve this. So there's all kinds of skills in here, guys. When you get to section 9.4, probably over the weekend, because probably starting right about tonight, you shouldn't bother with anything on chapter 9, or you should do very little on chapter 9. You should be focusing on the exam number 2. But probably you're going to get stuck here over the weekend. I do hope you either contact Lisi or myself over the weekend so we can help you over this. This is weird stuff. I want to do one more problem tonight on this, and then that's it for the night. Okay. Before we go tomorrow night, like I said earlier, Lisi and I are going to figure out a way to kind of help you review for exam number 2. I would say come loaded with questions. Okay, if you have anything, go back. The practice exam that I put on Canvas should be the last thing you look at. The test will not be multiple choice. The test will all be show your work. But the practice exam gives you some ideas. So that would be a good thing just to kind of go over. I would go over my lecture notes for chapter 8E and chapter 8I. That would be the thing I would study, the lecture notes, the problems that I do on the board. Go back over those. They should be in your notes, but they're also on YouTube, or I've got them in Canvas somewhere. Okay, that's what I would study. But come loaded tomorrow night with whatever questions you want to ask. All right, last question of the evening. Can I erase all this? That wasn't the last question. Can I erase this? Anybody yell at me? Okay. Okie dokie. 6x to the negative 2 plus 13x to the negative 1 plus 5 equals 0. Okay, I want to do it real quick, or at least get you started. I will be honest with you, there's 2 ways that this problem can be done. I'm going to show you one way using the substitution that we've been doing. There is an alternate way, and if you figure out the alternate way, I have to give you full credit. But here's substitution. I don't know, what variable should we use now? F for Foster. Okay. So your new variable always is the lowest power, x to the negative 1. That means, that implies that f squared is x to the negative 2. Because if you square both sides, that'll get that. So that means this problem is 6f squared plus 13f plus 5 equals 0. I think I copied wrong. Hang on a minute. This has to be a -5. I'm sorry. Sorry, beg your pardon, copied wrong. Okay. So, crud. This is AC is negative 30. So what multiplies to make negative 30 and adds to 15 or to 13, that'd be 15 times negative 2. So I have 6f squared plus 15f. Oh, Bach would have done it differently. Minus 2f minus 5 equals 0. Take out a 3f here. That leaves 2f plus 5. Here I can take out a 1, leaving 2f plus 5. Remember the trick about the negative signs and all that kind of stuff? So we factor the 2f plus 5 out, and we get 3f minus 1 equals 0. So 2f plus 5 equals 0, or 3f minus 1 equals 0. F is negative 5 halves. F is 1/3. Okay. So again, that was just ugly. You had to factor this with the AC. That was just plain ugly. But anyway, we get down to here. Okay, solve it. Okay, now what I have to do is unsubstitute. And this is where it gets tricky. The trickiness on all these isn't the substitution, and it isn't the factoring. Okay, substitution is kind of straightforward. You can do that through memorization. Factoring, we've been going over that for a month and a half now. The trickiness is, oops, how do I get rid of the f and go back to my original variable? So right here, x to the negative 1 . Okay, we replace f with x to the negative 1. We replace f with x to the negative 1. All right. How we solve this depends on how you see the problem. For example, what if you saw this as a negative power and you said, oh, this is 1 over x equals negative 5 over 2. And then you cross multiply. Negative 5 times x equals 2. Okay. X equals negative 2 divided by 5. That would be one way that you could do this problem. You could say, negative power means flip it. Okay, and you flip it, you get 1 over x, and then you go, it's a proportion. Foster loves proportions, so I must be on the right track. And you are. Okay, cross multiply, then solve. I'm done. The alternate way to do this problem, same thing, you substitute x to the negative 1 equals negative 5 halves. What if you raised both sides of this to the negative 1 power? Now I'm showing you 2 different ways. You might even come up with a third way. I don't care, as long as you use proper math and get the same answer I get, we're okay. If you raise a power to a power, what's negative 1 times negative 1? Positive 1. So this becomes x to the positive 1 equals, whoa, wait a minute. What does a negative power do to a fraction? Flips it over. So this gives me x equals 2 over negative 5. However you want to do it. Oh, wait a minute. Stop. I'm being stupid. Sorry. I beg your pardon. Erase if you have. I have no idea what I was doing here. this should be x to the negative 1 equals 1/3. I just was redoing this problem over again. And I have no idea how I got that done. I'm going to talk about residual damage from falling down and hurting my ankle. How that hurt my head, I don't know, but I'm going to talk about that. Okay, I'm sorry. I just really screwed this up. Raise this this to the negative 1 power, this to the negative 1 power. This gives me x to the positive 1, because power to a power, we multiply, we get positive 1. Flip this over, and then we get x equals 3. So solution set, negative 2/5 from this answer, and 3 from this answer. Couple things I want to tell you. That stuff I've been telling you about, the fundamental theorem of algebra, it only works when your powers are positive whole numbers. That fraction, the problem we did just before where there was fractional powers, we have no idea what the answers are going to be. Here with negative powers, we have no idea what the answer is going to be. So that fundamental theorem of algebra is really cool as long as your powers are positive whole numbers. If they're anything else, it's not a very good predictor. Okay, with that, I am done. Come tomorrow night with questions. Lisa and I have some stuff to maybe help you on the exam. Hasta bye-bye, guys. See you later.
Hey, Professor. So, the exam number 2, that one for all of them, does that one for chapter 8 and 9, or?
No, just 8 and 8.
Oh, okay.
8.
Okay.
Remember, we had 2 chapter 8s. We had
Yeah,
chapter
I was
8.
kind of like confusing about it, but like, you were like, nah, nothing wrong. That's it.
Okay, cool.
All right, thank you.
Yep,
Professor, we're not doing anything for roll tonight, correct?
correct. And I doubt that I'll do anything for roll for the rest of the semester.